This video is going to go over problems from the AP Calc Bible. I'm looking at page 27 where we are approximating area when given data only. So the first problem gives us a table and it's using it to estimate the area of a plot of land. The measurements are taken every 15 feet for the 120 foot long plot of land. Y is the distance across the land at each 15-foot increment. So we want to find an approximation for the area using all 6 methods. So the first one, using the trapezoidal rule, since the widths are equal, they're all 15 feet apart, we can use the trapezoidal rule. If they would give us a chart and they were unequal widths, we would not be able to use the trapezoidal rule, and we would have to find the area of individual trapezoids and then add them together. But here the area is approximately b minus a over 2n is the formula for trapezoidal rule. So 120 minus 0 over 2 times there are 8 trapezoids. And then we're going to take the function's value at 0 plus 2 times all the function values at all of the intermediate x values, and then f of 120, which is the end. So notice the coefficients are 2 for all the intermediate terms. And then we can figure out based on the table what those values are and sum them up. If we're using midpoints, now if we're using midpoints and we're going from 0 to 120 and we're using 4 midpoint subdivisions, the width is 30. So if you see, I put marks here for 30. So the first rectangle that we would have would go from 0 to 30. The second one would be from 30 to 60. The next one would be 60 to 90. And then the last one, 90 to 120. So think about the middle. The midpoint of 0 to 30 is 15. Between 30 and 60 is 45. 60 and 90 is 75. 90 and 120 is 105. So we're going to take b minus a over the 4 subdivisions, the function at 15 plus the function at 45 plus the function at 75 plus the function at 105 to get that approximation. C asks for the average using the trapezoidal rule. Well, we use the trapezoidal rule above. This is basically asking for average value. So remember, average value is 1 over b minus a, integral from a to b of the function. Well, we estimated this integral by using the trapezoidal rule and came up with that answer in part A. So now we're just going to take and multiply by 1 over b minus a. Okay, and that'll give us that answer. And we're basically finding the average distance across the land. Now E and F, they're asking for left endpoints and then right endpoints. So using that table, if we have to use all of the values and we're using the left, there are going to be 8 of them. Okay, so I'm going to look back to that chart again. So if I'm using the left, I have 1, 2, 3, 4, 5, 6, 7, 8. So the first interval from 0 to 15, the left will be the function at 0, 15 to 30 will be the function at 15, 30 to 45 will be the function at 30, all the way up to between 105 and 120, the left is 105. Now out in front is b minus a over the number of rectangles, which is 8, and then we can use the chart to fill in the function values to get our answer. Now, if we're using the right, we're going to go back to that chart and do the same thing, but when we're looking at the rectangle from 0 to 15, the right's going to be the height at 15, f of 15. 15 and 30, it's going to be f of 30, and so on, up to between 105 and 120, the right endpoint will be the function's height at 120. In front of that will be b minus a over n, which were 8 rectangles, and then we can come up with the answer. Okay, now the next one is approximating the area with unequal subdivisions. So as I mentioned above, this is where you have to do individual rectangles and trapezoids. So since 0 to 2, 2 to 5, 5 to 10 are unequal, we're just going to find the area of the trapezoid from x equals 0 to x equals 2. So it's 1/2, the width is 2, and then B1 plus B2 would be the heights of the trapezoid. This height would be f of 0, this height would be f of 2, and then we can find the area of that trapezoid. Then we're going to do the same thing. 1/2, the width is 3, and then f of 2 plus f of 5. And then the last one is the area of this trapezoid, which is 1/2, the width is 5, f of 5 plus f of 10. And then we can sum that up. Now, if we're using left endpoints, we basically just have 3 rectangles. So, when we do the first one, base is 2, so that length, basically length times width. Length is 2. They want us to do the height of the rectangle using the left endpoint. Okay, which is going to be f of 0. And then the next one, the width is 3. The left side is going to be the height at 13. Or the height is 13. It was at f of 2. And then the last one, the width is 5, and the left is f of 5, which was 11. To do the right, we're just going to go do the same thing. The widths will be the same, but instead of doing f of 0, we do f of 2. Then instead of f of 2, we do f of 5. And then instead of f of 5, we do f of 10. Okay, the next question is on the second fundamental theorem, example 3. So notice we use the second fundamental theorem when we're taking the derivative of an integral. Now this is the hardest scenario because we can only use the second fundamental theorem when the bottom limit of integration is a number, and it's not. The bottom and the top are both variables. So we are going to assume that there lives a number, I called it a, between x and x squared, so that I can break this up into the derivative with respect to x, the integral from x to a of the function, plus the integral from a to x squared of the function. Okay, so that's the first step. Then to use the second fundamental theorem on this first integral, we have to flip the limits of integration, so we're going to make that integral negative. And then the second one I'm just going to do in the next step, so I just rewrote it. Okay, so the first one, because the bottom limit is a number and the top's just an x, we're going to replace that t with an x. So we'll get negative square root of x to the 5th plus 2. Now this next one's a little bit harder because x squared is like a u. So we're replacing the t with a u, and then we have to multiply by u prime. So if I replace that with a u to the 5th plus 2 underneath the square root, u is x squared, so x squared to the 5th is x to the 10th plus 2, then times the derivative of x squared. Okay, and then the last question was example 2 on integral as accumulator. So that is, I guess, on the same page. Yeah. Okay, so this one, we're going to use that net change theorem or that impossible integral idea. If they give you f of 0 and they want you to find the other values, you're basically going to set up an integral. For f of -4, we're going to say, okay, if we go from 0 to -4 and we integrate the derivative, once we integrate it, we get f of x. But we're evaluating that. So we're basically putting in f of -4 minus f of 0. Now, the limits of integration are backwards, so we should make that really negative integral -4 to 0. Okay, so when we get this answer, it's basically the opposite. Now, if you notice how I did this, f of negative 4, if I solved for it, if I took it to this other side, it will equal f of 0, which is 10, plus this integral. So I have 10, then the minus comes in because I'm switching those limits of integration. And now I'm going to look at the actual figure to figure out the area under the curve of the derivative from negative 4 to 0. And that's how I'm going to get that answer for f of negative 4. So they're using that net change theorem. Okay, the same thing with the next one. If we're going from 0 to 4 and we're integrating the derivative, it's going to equal f of 4 minus f of 0. So f of 4 is equal to the integral from 0 to 4 of f prime of x dx plus f of 0, which they told us was 10. And then I'm going to go to the picture to figure out this area. It was negative 4. Okay, and then the same thing's going to happen with the next two. F of negative 2, if I integrate from 0 to negative 2, those limits are backwards from what we want them to be. So I could make that negative integral from negative 2 to 0 of f prime of x dx. Then, using that net change theorem, this is going to be f of 0 minus f of negative 2. Okay, I'm replacing again the f of 0 with 10, using the area under the curve to get my answer. Okay, and the last one, the ones that are positive are a little bit easier because you don't have to worry about changing the limits. But if we're going from 0 to 8 and integrating f prime of x, it's f of 8 minus f of 0. We're going to use the area under the curve to figure that out. We're going to put in 10 for f of 0 because that was given, and then we can solve for f of 8. Okay, continue to email me your questions, and I will post